Hey guys, last couple of videos. I actually have this too big, I think. There we go. So we're going to talk about change of attributes here, and there are a couple ways to do this. We're going to look at the formulas first. So what happens if the area, find the area of the triangle, what happens to the area if the height is tripled? So if I have h equals 1, and I triple that to h equals 3, it's always easiest to start with a 1 somewhere. So if I do 1/2 base times 1, and then 1/2 base times 3 equals the area equals the area. What we can do is kind of take out this part that's the same. So we don't really need to look at that because it's the same in both. If we set those equal to each other and divided that out, they'd go away. So what happens is it goes from 1 to 3. So the area also triples. Okay. So that's not always the way it's going to work, but a lot of times it will. And number 2, the radius of a circle is increased by 25%. So if the original, the radius is 1, and the new radius is increased by 25%, so that's 1.25. What percent does the area of the circle increase by? So A equals pi r squared for a circle. So in my original, that r was 1, so A equals pi times 1 squared, or just pi. And then in the new one, A equals pi times 1.25 squared, or A equals, kind of cheating, 1.25 times 1.25 is 1.56 pi. So we went from an original of pi to a new thing of 1.56 pi. To go from 1 to 1.56, that is a 56% increase. So what percent increase? That would be 56%. That only works because this coefficient is 1. Okay. Take notes on that. Make sure you understand how we're doing it. Once we do a handful of problems, you'll probably be able to figure it out by yourself. They kind of stay the same and kind of change a little bit. So, and this is something totally new. You've probably never seen anything quite like this before. I really wish we could do this face-to-face, but all right. If I'm looking at number 3, oh, I forget I have to move it here, don't I? If we're looking at number 3, the length of a rectangle is increased by 20%. Okay, so the length of my first rectangle, length and width, and then the length of my second rectangle. If this equals 1 and this equals 1, then the new length, the length of the rectangle is increased by 20%. Then L equals 1.2, because that's an increase of 20%, and the width is decreased by 20%, so the width turns into 0.8. Don't worry, my drawings are not drawn to scale. That's not going to matter. Which of the following accurately describes the change in area? So area equals length times width. So for my original, we're going to do 1 times 1 is 1. That's the original. And for the new, we're going to do 1.2 times 0.8. 1.2 times 0.8 is 0.96. So the question is, how do we go from 1 to 0.96? It's definitely decreasing, so it's not increasing, it's not staying the same, and it's decreasing by 4%. Number 4, the force of attraction between two particles can be determined by the formula above, in which F is force. So I always come over here and define my variables as I'm reading. F is force, R is distance. That's kind of weird. Q1 and Q2 are charges. Q1, Q2, charges. If the distance between the two particles is doubled, so if I have original and new, the original is going to be 1, and if the distance between two particles is doubled, then the new one is going to be 2, because distance is r. What is the resulting force of attraction? So F is my question mark. That's what I'm looking for. The original fraction. So if my new equation is, or my original equation is 9q1 q2 over 1, and then my new equation is F equals 9q1 q2 over 2. What has happened to the force? Well, we've got some stuff that stays the same. What stays the same? This 9q1 q2 and 9q1 q2 are the same. So really we can kind of disregard that. Force equals 1 over 1, and the force equals 1 over 2. So what happens to the force? It goes from 1 to 1/2. So what is the fraction of the original force? Looks like it should be 1/2. Oh, but that's not right. What did I miss? Do you see it? Do you see what I missed? I missed something. My original equation, r is squared. So if the distance is squared, that's 2 squared and 2 squared and 1 squared and 2 squared. So that's really 1 and 1 over 4. So it's not this guy. It's this one. So that r squared is that super important piece. I keep track of all of those little pieces of information. I'm doing this at like 2 in the morning, so I'm missing stuff. If I miss anything else, call me out on it. All right, erase, erase, erase. Where's my dumb smartboard when I need it? I'm not doing a very good job of erasing tonight. All right. Question number 5. The volume of a cube is tripled. So we're talking about volume. Volume of a cube is V equals S cubed, because all the sides are the same. The volume is tripled, so it's going to be multiplied by 3 in the new one. The length of each side must have increased by approximately what? So if V of the original is 1, 1 equals S cubed, and the new one is tripled, that means that's going to be 3 equals S cubed. So to solve those for S, we've got to take the cube root of everything. So the cube root of 1 equals S, and the cube root of 3 equals S. So we've got 1 for our original, and then the cube root of 3. I'm cheating and looking at my answer key because I've already worked it out. Cube root of 3 is 1.44. So how do we go from 1 to 1.44? It's that 0.44, and 0.44 in percent form is 44%. Number 6, we've got another crazy equation. Electric power is P. So P is power. Keep track of our exponents this time. Power related to voltage, V. Getting you guys ready for physics. And then R is resistance. R, resistance. If the voltage was halved, so if I have my original, and I have my new, if the voltage was halved, so V equals 1, and then over here, V equals 1/2. Voltages were halved, how would the electric power be affected? So I want to know about power. So P equals 1 squared over R, and P equals 1/2 squared over R. The R is the same, so we don't have to worry about that. So P equals 1, and P equals 1/2 squared is going to be 1/4. So how do I go from 1 to 1/4? 1 to 1/4 is going to be a decrease. So it's not going to be 4 times greater. Electric power not going to be 2 times greater. It's not going to be halved. It's going to be 1/4 of what it was, because it went from 1 to 1/4. Hopefully you're getting kind of a handle on this. All we're doing is reading, defining terms, writing the equation, and then comparing the two equations, basically, sometimes solving. And if you have the same thing essentially on both sides, same thing in both equations, you can kind of ignore that part. So go on, look at number 7 while I'm erasing this. Oops. It's been a minute since I made a video. Correct. Lucky number 7. Should be going to Vegas or something. All right, Julia has a square fence that encloses her garden. So Julia has a square fence. That means all the sides are the same, right? Because it's a square. She decides to expand her garden by making each side of the fence 10% longer. So she's making a bigger fence. So 1 is our easiest thing to use. If it's 1 by 1, and now it's 1.1 by 1.1, right? She increased it by 10%. 10% is 1. After the expansion, the area of Julie's garden will have what increased by what percent? So the area of the original garden is just 1, because that's 1 squared. And the area of the new garden is 1.1 squared. It's going to be 1 to 1.1 times 1.1 is 1.21. So what have we increased by? How many percent? You got it. A right circular cone has a base radius. So we can draw a cone. And then I'm going to change color just a little bit. So R equals, and the height equals base radius of R and a height of H. If the radius is decreased, so if we make this 1 and this 1, and then we draw another cone, you draw a triangle and then a circle underneath it, you'll have a cone. And we have a radius and we have a height. So this says the radius is decreased by 20%. So if I decrease 1 by 20%, I get 0.8 equals R. And the height is increased by 10%. So if it increases by 10%, then H equals 1.1. Which of the following is the resulting percent of change in the volume of the cone? So V equals 1/3 pi R cubed. No, pi R squared H. Sometimes I have to look at my formulas. So pi r squared h. So for my pink cone, let's see if I can go back to pink. We're going to do v equals 1/3 pi, and then r squared is going to be 1 squared times h, which is 1. That's going to give me 1/3 pi. All those ones are going to cancel out. And if I go back to my purple cone, we're going to do 1/3 pi, and then r squared, 0.8 squared, times the height of 1.1, and we are going to get 1/3 pi times 0.704. Now notice that I just, because I have the 1/3 pi here, and I have the 1/3 pi here, I don't really need that. All I need is this part and this part. So we've got 1 over here to 0.74. So how do I change from 1 to 0.74? Well, what's 1 minus 0.74? That's going to be our decrease. It's going to be about 30%, 29.4. That last one is kind of confusing. Remember, if you have something in both equations, like pi or a fraction, you can just leave those out because you've got them on both sides. They're going to cancel out anyway. And always look at your formula sheets. It is faster if you can memorize some of these, but you will have a formula sheet. It's at the top of the folder. Since you're not testing right now, you can also Google it. You're not under a time crunch. Remember, the SAT is timed. So all of this erasing would definitely take a bite out of my score. All right. We did 8. Now we got to do 10. Can we see all of 10 at one time? Or 9 at one time? I'm going to use my mouse. Maybe. There we go. The area of a right trapezoid can be found using the following formula, and it even gives you a picture. That's nice. If the lengths of A, B, and C, D are halved, and the height is doubled. Okay. So if we start with A equals 1/2 base 1 plus base 2 times h. And we just, well, let's see what happens when we do the new one. So A and B are both halved. So that's B1 and B2. So the new one is going to be B1 divided by 2 plus B2 divided by 2. And then it says the height is doubled. So this is going to be 2h. So if we distribute these like this, A equals 1/2 2B1h divided by 2. Those 2's are going to cancel out, plus 2B2h divided by 2. Those 2's are going to cancel out. And if we multiply this h over, I think we get B1h, which we have here, and B2h, which we have here, and everything has 1/2. So the area would be increased by 50%. The area would stay the same. The area would decrease by 25%. The area would decrease by 50%. I think because the multiply the height by 2 and the divide the base by 2 is going to cancel out, I think we're going to end up being the same. Area is going to be the same. Calvin has a sphere that is 4 times bigger than the one Kevin has. So we've got Calvin and we've got Kevin. Calvin has a sphere 4 times bigger. So this is 4 times bigger, and this is x. Could be 4 and 1. I don't know. In terms of volume. So this is V. The radius of Kelvin's sphere, so the radius is how many times greater than, how many times greater in length than the radius of Kevin's? So radius. So first of all, we need to look for the area of a sphere. I think it's 4/3 pi r cubed, but let me check. 4/3 pi r cubed it is. So if V equals 4/3 pi r cubed and V equals 4/3 pi r cubed, if Kelvin has a volume of 4 and Kevin has a volume of 1, right? Because that's 4x and that's 1x. Then we've got 4/3 pi in this equation that we can ignore, and we've got 4/3 pi in this equation that we can ignore. So I think we need to take the cube root. So if I take the cube root of both sides, we're going to get r equals the cube root of 4 is 1.587. And we take the cube root here to get rid of these cubes, right? Then r equals 1. So Kelvin's radius is going to be 1.587, and Kevin's radius is going to be 4. So the question was again, how many times greater in length is the radius than Kevin's sphere? Kevin's sphere bigger than Kevin's sphere. Voila, I think our answer is right there. Hopefully I can let you guys do a couple of these now without my help. Remember, you should be taking these notes, printing the PDFs, taking these notes, saving them for when you actually take this test. Right? And then in Schoology, when you go to take the quiz, try to do as much as you can from your notes, not just clicking the right answer because you know it's the right answer because I've already done it for you, right? This is not let Miss Doherty do all your work. This is learn how to do it yourself. And if you think of another way, I would love to discuss those. All right. Cool. Need that clicked over here. 10. Oh, special right triangles. This isn't a special right triangle unit. What are we doing with this? All right, let's see. In the triangle above, the lengths of the sides relate to one another as shown. So that's x, x, and x on the square root of 2, because it's 45, 45, 90. If a new triangle is created by, that should be by decreasing x, such that the area of the new triangle is 64%. So if we say this area equals 1, and that's going to be whatever x or the s squared is, right? Then our new triangle, A equals 0.464. Equals the side squared of our new triangle. And we just have to take the square roots, right? So if we take the square root of the original triangle and the square root over here, this doesn't surprise us that the side equals 1. And then over here, the square root of 0.4s equals 0.8. So how do I go from 1 to 0.8? It's a decrease of, you guessed it, 20%. Hopefully you're feeling a little more confident with these. That fraction decimal percent stuff that you had to do in middle school comes in really handy. Hopefully there's no PTSD about that. I know most of the geometry teachers have taught middle school, so we know all about that fraction decimal percent nightmare. Last two questions, I think, and I think they use the same crazy formula. All right. So this formula means absolutely nothing to anybody except a physicist. The amount of total energy emitted by a star is called its luminosity. So that's L, which is related to D, the distance away from the Earth, and B, its brightness, as measured in watts per square meter. If one star is 3 times as far from the Earth, so we make D equal 1, and then D equal 3, because it's 3 times farther away, and twice as bright, so B equals 1, and then B equals 2 of the brighter star, so this is star 1 and star 2. How many times greater is the luminosity? So we've got L equals 4 pi 1 squared times 1. That 4 pi is going to be the same, so we can take it out. So we've got L equals 1. Okay. And then over here for star number 2, L equals 4 pi times 3 squared times 2. Again, we've got that 4 pi on this side, so we can leave that out. And then 3 squared is 9. 9 times 2 is 18. How do we go from 1 to 18? Boom. I think that was the easy one. I imagine the second one is going to get a little harder. Astronomers see 2 equally bright stars. So brightness is equal. Brightness 1 equals brightness 2 in the night sky, but the luminosity of star A, so this is star A, this is star B. The luminosity of star A is 1/9 the luminosity of star B. The distance of star A is what fraction? So distance is what we're looking for. Okay. So, if the brightness is equal and the luminosity is 1/2, what if we take this equation and we divide it? So we divide both sides by 4 pi d squared and 4 pi d squared. These 4 pi d squareds would cancel out. So we would get brightness equals L divided by 4 pi d squared. And because the brightnesses are equal, we could set those equal to each other. I'm going to jump over to this side, to my left side of my screen. So in star A, right, if I have the luminosity, which is 1/9, actually, I know what that is. So luminosity is 1/9 divided by 4 pi d squared. And then in B, I've got a luminosity of 1 and 4 pi d squared. If I make this one 1, because I'm looking for the luminosity of A, distance of star A from Earth is what fraction? So if I'm looking for the distance of A, I can make the distance of B 1. So we'll make this a 1 right here. And because the brightnesses are equal, we can set these equal to each other. And then all we have is a proportion. So we can cross multiply. So that's going to be 1/9 times 4 pi, and that's just 1, equals, and then we cross multiply over here, 4 pi d squared. But do you notice it's the same on both sides? 4 pi crosses out, 4 pi crosses out. So 1/9 equals d squared. I take the square root of that, and we get 1/3 equals distance. So the distance of star A is 1/3 the distance of star B. And conveniently, we have an answer choice right there. Congratulations, that is all of the change of attributes. Hopefully those make sense. If they don't, either watch the video again or come see me in a Zoom room.